So now I'm going to do question 1. We're going to do the multiple choice questions. Just going to start from 1.1, which says that inertia is a property of an object whereby the object, option A says that the object needs a force to accelerate. Option B says that the object comes to rest when the force that has set its motion is removed. Option C says that the kinetic energy, it has a kinetic energy, the object. D says that is not able to move. So we all know what inertia is, right? It's a property that resists motion. So the option here is D, which says that inertia is a property of an object where the object is not able to move. Now we're going to go to 1.2, which says that a box of mass m rests on the floor of a surface which is accelerating upwards. The lift acceleration is A, and the acceleration due to gravity is G, right? The net force of the box is equal to what? So we're having a lift and we're having a box like this, right? And we know that the force of gravity is acting here and the applied force is acting up, right? So to find the net force, F net is equals to the force minus the force of gravity, right? So the force being m multiplied by acceleration minus mg, right? So this would be our net force. So our answer here will simply be C, right? Because we have our force here with acceleration and then subtracting the force with our gravitational acceleration. So this would be the answer C. Then 1.3 says that a learner drops an object from the 15th floor of a high building. 1 second later, the learner drops another identical object from the same position. As both objects are free fall, the distance between them is, so you're dropping, so this is the floor of the building, right? Let's say it's 20 meters and you're dropping, so you're dropping it, you're not throwing it, you're not you're just dropping it. So it's gonna go down, so this ball is gonna go down. Ball A will go down, right? And ball B will also go down after 1 second, right? So the distance between these, because it's a free fall, gravity is acting upon this ball, pulling it downwards, right? And the same with B, right? So the distance between them is going to increase. Obviously, if maybe you consider air resistance, which will try to prevent it from going down, trying to keep it up. So the distance between ball A and ball B will definitely increase, right? So we're just gonna take option A, which says increase. Now we go to 1.4, which says that a trolley with a mass m is moving at a constant velocity v on a frictionless track. A block of mass m is dropped on the trolley from the above. The final velocity of the trolley will be, so now you're having a situation where F is equals to ma, right? And the initial, so this is the initial force, right, of the trolley. So which means if it's traveling at constant speed, which means acceleration will be 0, right? So it's going to be 0 newtons, the force, right? So now what happens is we're having both mass of the trolley and the mass of the block that is thrown inside the trolley, and then we have our acceleration here. So to find the velocity, let's say F is equals to, so now because we're having the mass of the trolley and the mass of the block, these mass are both identical, so it's just 2m and acceleration, and we know acceleration is equals to v, change in v over t, right? So you can simply say equals to 2m change in v over change in t, right? And to find the the velocity, you simply want to say cross multiply. You have f multiplied by change in t is equals to 2 m change in v, right? And then you divide by 2m, so your change in v is going to be equals to 1 over 2 multiplied by f delta t over m, right? So you can see that our change in velocity, final is going to be half, right? So the final velocity, because the initial one was 0, right? So the final velocity will be half. So you can simply take option C as the answer. Then now we are doing 1.5, where an AC electric motor has power rating of 1.2 kilowatts. In 1 minute, the amount of work done by the motor in joules is. So what you can do here is this. So what you can do here is this. You can to find the work done by this power, you say power is equals to work done over change in t, right? And then you cross multiply, you have work done is equals to power multiplied by change in t. So the power that we have is 1.2 kilowatts, so you can multiply by 10 to the power 3 the kilo. And then time, you can simply use seconds or minutes. Let's just use the minutes, so it's 1 minute, right? So the work done here is 1,200 watts, which you can also write as joules, right? So you can say work done is equals to 1,200 joules. So this is the answer that I'm getting here. It's actually this option A here. I know in the memo you will find this answer here. So if by any chance your calculations you find this answer, please let me know in the comment section below. But otherwise, this is what I'm finding, option A for this question here. So now we're going to do 1.6. 1.6 says that a car travels at constant velocity. So the car travels at constant velocity towards a stationary listener. The car's hooter emits a sound of constant frequency as it approaches the listener. Which of the following statements regarding the frequency and the wavelength of the hooter are observed by the listener? So the first option says that both frequency and wavelength have decreased. So if, let's say, this is the listener, right, and this is the car, and the car is coming in this direction. So as the car comes in this direction, the wavelength decreases, right? The wavelength decreases. It decreases. So we know that V is equals to F times lambda, right? And we're observing frequency and wavelength, right? So if the wavelength decreases, right, then what happens to the frequency? So frequency is equals to V over lambda. So if wavelength decreases, then the frequency becomes higher, right? So it increases. So they're inversely proportional. So if we look here, because this car is coming towards the listener, so it means now that the wavelength is decreasing. So where in the option wavelength is decreasing? So this is the option for wavelength is decreasing. This is another option for wavelength is decreasing. So between these two options, they're right. This one is wrong because the wavelength is not increasing. This one is wrong because the wavelength is not increasing, right? So looking at these two options that I just underlined here, let's look at the frequency now. As the wavelength decreases, the frequency increases. So where is the frequency increasing? It is increasing on only this option here. So which means this option A goes out, out, out. We will consider option D in this case to be correct. right? Because the frequency increases as the car comes closer, whilst the wavelength decreases. Okay, so now we're going to 1.7, which states that the number of excess electrons which will cause a charge of -8 microcoulomb sphere is equals to. So we need to find the number of electrons, right? So the formula is N is equals to the charge over the charge of electrons, right? In this case, we have minus. You can put the minus if you want, or you don't have to. I'm just going to write 8 times 10 to the power of -6 because it's macro, divide by the charge of an electron, right? Which is 1.6 times 10 to the power of -19, right? So the answer, you just punch this in the calculator and see what you find, but you'll definitely find this answer here, which is 5 times 10 to the power of 13. Right, so these are the number of excess electrons, 5 times 10 to the power of 13. So the right answer here is B. Okay, so now we move to 1.8, which says that 4 identical light bulbs are connected, as you can see. So we have 1 light bulb, 2, 3, and 4 light bulbs, right? Then they say, how does the brightness and potential difference of L4 compare with the brightness and potential difference of L1? So what you need to note is this. If we're comparing L4 and L1, right? L4 is in parallel with L3, right? So these are parallel. So the fact that they are parallel, it means now if you write your V is equals to IR, which means now that the current is distributed equally, right? So it's distributed. If maybe we have a current of 2 amperes, sorry, then it means now that 1 ampere is going to go to this one, 1 ampere is going to go to this one. So current is distributed in each, right? So for the fact that this one would have 1 ampere of current, it means now that the voltage will be smaller. The voltage potential difference of this one will be small compared to the potential difference of L1. L1 potential difference would be larger, right? Would be larger compared to L4, right? And then if the potential difference is smaller, definitely the current of L4 will be smaller also, right? The current, which is I, will be smaller because I said if we are talking of 2 amperes and this L1 has 2 ampere and these only share 1 ampere because they're identical, remember that. So it's going to be 1 ampere, so current is smaller. So this just tells you that L4 will bright less compared to L1. So we can take this answer here, less. And the potential difference of L4 will be less compared to L1, right? So we'll take this option here, as I indicated that the potential difference of L4 is going to be smaller due to the current, right? And then the potential difference of L1 will be larger. So the right option here is A. Then we go to 1.9, which says that which of the following devices cannot operate with both direct current and alternate currents, right? AC and DC, right? Currents. So one obvious answer here is just going to be B, right? These other ones can operate in both currents, so the transformer will not. Fine. Then we go to 1.10, which says that in an experiment on the photoelectric effect, a scientist shines a green light, right, on a metal surface, right, and observes electrons ejected from the metal surface. So later the sensor shines a blue light. So this is important. So it first shines a green light, then shines a blue light. So these two lights have different wavelengths, just so you know, with the same intensity so the intensity is the same, but we don't know the wavelength of these two properties of light, right? So which of the following statements will be correct, will be the correct observation? So the first statement says that the number of ejected electrons per second increase, the number of electrons increase, the number of ejected electrons per second will decrease, the maximum kinetic energy of the ejected electrons will increase, the speed of ejected electrons will decrease. So how we can analyze this, we need to know your visible light spectrum and know the wavelengths of your, okay, you don't really have to memorize them, but you need to know that if this is the blue light, right, and it goes up to the red light, so you need to note that the wavelength, what is the wavelength? Does the wavelength increase or decrease, and going in which direction? So the wavelength going in that direction, it increases, right? Increases. So you need to know what other properties of light come after. So there's blue, and then here in between you can find your green light, right? And then going up to the red light, right? So you know that going in that direction, your wavelength increases, right? So if your wavelength increases, what happens? Fine. So because I'm more interested in analyzing the kinetic energy here. Why? Because your E energy, photoelectric energy, is equals to your H multiplied by C over your lambda, which is equals to the work and kinetic energy, right? So we want to note whether which kinetic energy will increase, right? Whether it will increase or not, because we first use the green light, and the green light is this one here, which is here. So basically, the green light has because wavelength increases going in that direction, which means green light has a higher wavelength, right? Compared to the blue light. The blue light has small wavelength, right? And we are starting from the green light to the blue light. That's how we are lighting in this experiment. So it means now that if you go to this formula that I just indicated here, it's going to be H multiplied by C over, because we're starting from the green light, so the green light, right? And then I transpose this W to the other side with minus W is equals to kinetic energy, right? So the kinetic energy of the green light is going to be smaller, right? Why is it smaller? Because it has a higher wavelength, right? The wavelength, it's here, wavelength is higher compared to the blue one. And since we're starting from green to blue, then it will change. It's going to be, instead of being the green light, now we'll change and use the blue light, right? So the blue light has a small wavelength, right? So the fact that the wavelength is small, which means the kinetic energy will be larger. So the kinetic energy is increasing from the green light to the blue light, right? So we can simply take option C now in this case, because now we know that kinetic energy increases from a property of light that has higher wavelength to a property of light that has lower or smaller wavelength.